Hi, I'm Baoping Liu and I'm going to present our work, TI2Net, Temporal Identity Inconsistency Network for Deepfake Detection. Deepfake detection has been a rising topic to protect people from deepfake. Compared with real videos, the low similarities among fake video frames can easily expose deepfake, which can be seen in the example of Figure 2. Temporal identity inconsistency-based detectors applicable to not only face swapping but also face reenactment manipulations. Besides, temporal identity artifacts are reference-agnostic, which means no reference sets are required. Framework of the proposed method is shown here. The raw sequences of video frames is transformed into identity vector first. Then differencing operation is adopted to generate temporal difference. From temporal difference, RNN then learns the temporal embedding, which represents a temporal identity inconsistency. I will introduce the proposed framework in three parts according to its flow. The first part is pre-processing and differencing. After frame extraction and face cropping, frame sequences are transformed into identities by identity encoder. To better capture discriminative temporal patterns between real and fake videos, rather than making the network overfitted to identities in videos, we applied differencing operation to identity vectors and get the corresponding temporal difference as is shown in Figure 4. We use recurrent neural networks to present the temporal identity inconsistency by embeddings. In detail, we adopted gated recurrent unit, which is known to have better long-term memory than conventional RNN structures. The overall loss includes cross-entropy classification loss, the triplet loss, and the anchor-positive regularization term, where the triplet loss pulls the anchor and the positive samples closer and push the anchor and the negative sample further. We also adopt the anchor-positive regularization term to help the convergence of triplet loss. Here we show the results of our experiments. We first compare our methods with SOTA methods, including the detectors based on spatial and temporal artifacts. It can be seen that our methods outperform SOTAs in both in-set and cross-set experiment settings. In ablation study, we first researched the effectiveness of differencing operation. We noticed that the differencing improves the generalization ability and prevents the framework from overfitting to certain identities. We also noticed that the anchor-positive regularization term contributes to the convergence of triplet loss by avoiding simultaneous increasing of anchor-positive and anchor-negative distance. We also evaluated the robustness of the framework. It can be seen that our framework remains quite robust performance even at very high compression degree. And our framework outperforms LRNet and exception against additive noise. Apart from the contribution in generalizable and robust deepfake detector, we noticed our framework still gets overfitted to thin identities, which remains to be improved in the future. Thank you.